One of the Hubble Space Telescope's most memorable moments was observing the fragments of Comet Shoemaker-Levy 9 impact Jupiter in July 1994. This was a huge astronomical event that captured the attention of the public across the globe. But what most people don't know is that Hubble came close to not getting those observations. The telescope encountered some problems that might normally take over a month to solve just days before the comet impact.
Shoemaker-Levy 9 is a comet that was discovered by David Levy, Carolyn Shoemaker, and Gene Shoemaker. We had about 9 months of warning that this comet was going to hit Jupiter. I knew from the calculations we had done beforehand that if Hubble was working at the peak of its game, that we would get images that far surpassed images that could be taken with any other telescope on the Earth.
So we knew the comet Shoemaker-Levy was going to impact Jupiter on July 16th. So we wanted to make sure Hubble was ready for that.
July 5th, 1994 started out as an ordinary day until we were called and told that the Hubble had been commanded into inertial hold safe mode because it appeared that it was misbehaving and not executing the proper commands.
When they command inertial hold, all those commands that were loaded stop executing. We'd tell it to don't look at those anymore and just hold steady.
You know, your first response is sort of an empty feeling in the pit of your stomach, like, oh no. We have this huge event coming up and the telescope's not working.
We had about a week to resolve the vehicle issue and bring it back to normal mode.
The spacecraft was not executing the commands in the stored command sequence that it was supposed to be. It looked like it was doing something completely random. So we immediately suspected that there was a memory unit problem.
We were lucky because the previous mission we had done, we installed a coprocessor.
During the first servicing mission in December of '93, the coprocessor was basically a memory upgrade, an additional memory to augment the DF-224 flight computer.
Now this coprocessor has what we call a shared memory that both computers can use. So the shared memory wasn't really configured yet to be usable. But we knew it was there.
We verified different configurations and different architectures that we could test out, and we found that it was no issue to swap out the memory.
So we started doing that, and things were going extremely well. And suddenly, while we're in the middle of reconfiguring it, we were told that the spacecraft had entered zero gyro sun point, which is a more serious version of safe mode. What it looked like is that we had just lost 2 gyros simultaneously, which that can't happen. We had just replaced all 6 of them in the first servicing mission along with the coprocessor. This just couldn't be happening.
I remember just going, what's going on? I didn't know what was happening. Yeah, because the hardware guys looked at the gyros, they were fine, but the software said that they had a problem with 2 of them.
Here we are halfway through the reconfiguration and we're in deeper trouble than we had thought.
I started looking at the time between the 2 events. Started figuring out, well, okay, it's 2.5 days. What is that in hours, minutes, and seconds? I saw the number, and it was really obvious at that point what happened. There was an overflow in the computer. Finally discovered that we have this thing called a gyro good count that counts up how many seconds has there been since the last bad gyro count, if you will.
When the gyros change mode, this counter gets reset. Typically this will happen several times a day. Well, because of the work that we've been doing for the last 2.5 days, this counter never got reset. And when it overflowed, or when the counter value went past the highest number it could count to, bad things happened in the code.
Once we discovered that and knew there was an overflow in the software, we knew we didn't have a computer problem. It was easy. And then it was just, now we just have to recover. So by the time we finished that and got back up into the science operating mode, it was probably middle at the end of July 9th, so in plenty of time before the observations.
Well, as soon as we heard that Hubble was back on track, we were like, yes, ready to go.
It allowed the Shoemaker-Levy campaign to go forward, and I'd hate to think what would have happened if we hadn't got the coprocessor in and got it checked out.
We retreated to our offices and waited for the impact. Wanted to see the pictures just like everybody else did, so we were watching it on NASA TV just like the rest of the world was. And I remember seeing a press conference at the Science Institute announcing it, and they were waiting for the pictures when Heidi Hamill came in, waving the picture, the first picture from Hubble.
Proper shot, she's going in. Camera 3. She's bursting in, go Heidi.
That it probably indicates we're dealing with larger objects than was concluded by Ashfog and Benz. And I think we may have some up-to-date information from Heidi Hamill.
Gene Shoemaker said he would be personally astonished if we saw nothing. Well, he's not going to be astonished. We actually saw some amazing things.
The comet delivered. I mean, it delivered big time. It had big black spots, and if you looked at certain colors of light, it had white spots, and it had the rings, and it had plumes, and it had big giant storms. And I was really proud to be a part of that, and I was really proud that all the engineers and scientists could pull together and make that happen.
Comet Shoemaker-Levy 9 added to our knowledge of Jupiter's atmosphere and the physics of atmospheric explosions, and even influenced some space policies and finding near-Earth objects that could impact us. Thanks to the entire Hubble team, the telescope was able to make these impactful observations and perform all of its incredible science over the past 25+ years. The stories don't end here. Stay tuned for more Hubble memorable moments.